So moving on then to your what's called your Bowditch table. I'm going to split this into two videos here. Firstly, we're going to start off with the top half, what I would call the easy half. Okay. What I have done is after the second video there where I've calculated my whole circle bearings, I've copied in my whole circle bearings, and from the diagram from the second video as well, the bearing video, I've included the length of each line. Okay. Now we have to work out what we call the partial eastings, or the difference in the eastings. But to do that there, we have to start with coordinates. So we're going to start and give station A arbitrary coordinates. Okay. I normally start with 100.000 eastings and 100.000 northings. That just minimizes the chance of us ever going into negative figures. Whereas if you start at 0, you're dealing with negative figures in your calculations, and it just makes things a wee bit trickier. The alternative would be to use actual GPS coordinates, but they are substantial numbers. And for this level of site check, it produces the same check on the traverse to millimeter accuracy anyway. So we'll just start with arbitrary coordinates of 100, 100. Okay. What I would say is early in your career, it's probably best to do the eastings first as a column and the northings second as a column. Okay. Before we do our cumulative calculations, what I found is it reduces any error in the difference in the two formulas. So the two formulas are quite simple: length, sine, theta. Okay, L sine theta, and to simplify that, I have wrote length, sine, and the angle. Okay, and it's basically using the two figures side by side. Okay, so I am actually going to do this as we speak. So 13.458. 58 sine, and the angle has to be input in degrees, minutes, seconds format, 2400, close your brackets, and we get there 9.280. So it's important to write down the reading as it displays on your calculator as well, and we'll hopefully see that in a wee second. Okay. So we then simply move down, and that's what I'm saying. For familiarity, we stick with the sine calculation, not to confuse things. So 30.687 sine, 54 degrees, 46 minutes, and 40 seconds. Close the brackets, and we're getting 25.069. So we're rounding up to 3 decimal places there, guys. Okay. The next one then, 16.224 sine, 322 degrees, 01 minutes, 00 seconds, close your brackets. And we're getting a negative figure there. So it's important that you put the negative figure in, 9.985. And again, we're rounding to 3 decimal places. That'll be important. Finally, 32.009 sine, 229 degrees, 35 minutes and 30 seconds. Close your brackets, and we're getting a negative figure there, minus 24.373 to 3 decimal places. You simply go along to your northings column, and this time it's the same calculation essentially, but with cosine in between. So 13.458 cosine 136 degrees, 2400. And we're getting a negative figure there of negative 9.746 to 3 decimal places. Moving on to the next one, 30.687 cosine 54 degrees, 46 minutes and 40 seconds. And we're getting a figure there of 17.698. Sorry, 699 to 3 decimal places. Next then we have 16.224 cosine 322 degrees 0100, and we close the brackets, and we're getting a positive figure there of 12.787, and we actually round that up to 3 decimal places, 788. And finally 32.009 cosine 229 degrees 35 minutes and 30 seconds. And make sure you put the symbol in. And we're getting a negative figure there of negative 20.749. Now, what that means is we can quickly do a quick check on this here, okay? We can check this column here to check approximately how far we are out. So 9.280 plus 25.069 minus 9.985 minus 24.373. We are getting 0.009 millimeters there, okay? And we do the same with the northings. We tally these up as well, starting off with a negative number, minus 9.746 plus 17.699 plus 12.788 minus 20.749. And we are getting 0.008 there. So this is the first indication of your linear misclosure using your taping or your total station distances. So 9 mil in the eastings and 8 mil in the northings. How does that look like for the coordination of this? Well, we start off at station A with 100. We're going to use the easting column here. And again, we'll just, to simplify the whole thing, we'll do the eastings first. So what we're basically doing is 100.000. We type that into our own calculators. We go to our easting column, and the figure is positive. So 100.000 plus 9.280, because it's a positive figure. Okay, so very simply, that is 109.280. Okay, and because this is a cumulative figure, we're now using the figure of that we've calculated, 109.280, and the next figure is positive 25.069. So we add 25.069, and that gives us 134.349. Okay. We then take that figure cumulatively, and we take away 9.985 because it's a negative number. 9.985 equals, and I'm getting there 124.364. And finally, we are taking 124.364 and deducting 24.373. And that is basically giving us a figure of 99.991. And we work out we check our linear misclosure. So we check your initial reading and our final reading there, and we can see that it is indeed 0.009, and we are short that amount. So that is how far we are off. Okay. We do the same with the northings. 100 minus 9.746, and that gives us 90.254. I'll just rush through these. Take that figure, and the next figure is positive. So we add that. So we're going to add 17.699, and that gives us 107.953. You then take that figure and add the 12.788. We get 120.741. And finally, we take that figure and deduct the 20.749, and that gives us 99.992. And just to check on that, 100 minus 99.992, that leaves us minus 0.008 short. Okay, so basically what we then have to do is use a Bowditch table or Bowditch rule to do corrections to this here to ensure that this ends up as 0 or as close to 0 as possible. So we need to make a correction of positive 0.009, a correction of this to positive 0.008. Okay, and just while we're doing that there, we should tally up the length of the survey. So 13.458 plus 30.687 plus 16.224 plus 32.009, and we tally up there as getting 92.378. That's the total length of the survey, and that's important because we need to use that figure in our Bowditch corrections, and I will show that in the next video.